Hello and welcome to this episode of our discussion series on the science of cities at the Madras Complexity Collective. This is Nishanth Kumar, and in this episode, I have a conversation with Dr. Anand Sahasranaman, who's also from the MCC, on studying Indian cities, specifically on asking questions of how things scale with city sizes in India. Anand has been studying urban scaling in Indian cities for a long time, and I spent some time asking him about some of the interesting aspects of his work and things to consider when looking at urban systems in India. I hope you enjoy this, and if you do like this, do check out more episodes of this series and more at madcomplexity.in. Thank you.
Start off, and maybe we can start by you can tell us a little bit more about how you describe this idea of scaling and how you've applied it to idea of cities and city systems specifically, and then maybe we can talk a little bit more about like India.
Sure. So thanks, Nishant. Really nice that you're doing this conversation in person.
Yeah.
This work that I've been involved in scaling now, I think over the last, I would say, 6 or 7 years, right? And the initial sort of the breakthrough work in this came out, I think, in about 2007. With the Betancourt and West paper, where they really opened up this sort of new way of looking at cities as systems, right? So what urban scaling does is it offers us a framework to understand how to think about an entire city system, right? So nations, have histories, cultures based on which their systems develop over time, city systems develop over time. And what scaling gives us is one way to understand that, a way that is grounded in science. Now, what specifically do we mean by scaling? I think the simplest way I would say to think about it is how do different cities within the same system relate to each other based on their size, right? This has, of course, its antecedents in biology. Where the idea of allometric scaling, biological scaling, is quite prominent, right? And what Betancourt, West, and their collaborators did was to say, can we take that framework and apply it to cities? Because cities, as we spoke about earlier in a conversation with Luis, have often been described as organisms, right? That grow and die, and so what they did was really take that metaphor and make it a science in this context. Now, if you think about what does scaling mean for a city system, the simplest way I can think about it is to say that if you have two cities in a system where the size of one city is twice the size of the other, right? And by size, let's say, I mean population, right? So the population of one city is twice that of the other. Now, what should you expect different attributes of a city should be in a given city system when its size doubles? So if I'm living in a city with a population of 5 million and you're living in a city with a population of 10 million, and let's say that, the GDP of my city or income of my city is, 1,000 rupees per capita, what should I expect is the income in your city? Should it just be 1,000? Should it be less? Should it be more? Right? Now, our instinct in general, and we do this without thinking, is to just assume that things scale linearly. And that therefore per capita income in your case will be 1,000 as well, but just total income would be more. So if my city has a population of 1,000 people, each with an average income of 1,000, which means my total GDP of my city is 1 million, right? In your case, I would just expect that to double to 2 million, right? Similarly, with any quantity that you take, if I say that crime in my city is let's say there are 100 serious crimes in my city, I would expect 200 in yours. Now, implicit in that is the assumption that things scale linearly when you go up and down a city system in terms of population, right? But there is no reason to actually believe this, right? I mean, why do we assume that that would be the behavior, right? And I would say that in some ways that offers us a null hypothesis to say that, well, we don't know what it should be. So maybe the most reasonable assumption is to make that the rates at which things happen don't change. But of course, this is not based on any, solid theoretical framework. It's just an assumption, right? What scaling does is it really offers us a scientific framework that explains how to think about or what to expect when we go up and down these scales. And so at its barest, it's really how do the properties of cities in a system change with size. And this could be any property. It could be the length of roads in a city. It could be the amount of innovation that's happening in a city. It could be the number of cars in a city. It could be the number of crimes in a city. So really any property you want of a city, what should you expect about its variance with size? So that really is what urban scaling is. And the work that, that Louise and others have done is really to say that urban theorists, especially economists, geographers, have tried to model these processes of cities, right? And what the more recent work on urban scaling has really taken those, foundational or classical ideas about urbanization in cities and really applied them in the context of network models with constraints on, transportation and costs, right? And so when you build a network model of a city, then you start, getting a sense of what to expect. Because networks behave in certain ways, in certain predictable ways, right? And that now gives us a basis to understand or to form expectations of what will happen when cities grow, right? Or what will happen in cities of different sizes in a given system, right? So, and this is what scaling does, right? And now what they found was that, there are different kinds of expectations we should have for different quantities. And we can talk about that. But really, this to me is a sense of what scaling is. It gives us a way that is grounded in theory to form expectations of how cities behave up and down a city system. Yeah.
Yeah. So maybe just we'll try to think a little bit more about that question, right? So quantities. When I remember reading the Jeffrey West and co. Their work, the allometric scaling was about metabolic rates and how they change for different species based on their size. So the idea was that the larger an organism is, does the metabolic rate does it get higher and higher? The idea is the larger the animal, is it more efficient in processing nutrients?
Yeah.
So that's a fixed quantity, and the idea of allometric scaling was also fixed for quantities of along the rates of metabolic rates. So I was wondering more about when you think about a city, what are the different kinds of quantities that you think about? Maybe you can give us like 2 examples or 3 examples that can show us the variety of quantities that you look at and what you can infer from them and how it's useful for us to understand a city system.
Yeah, that's a great question. So I think in biological scaling, as you talked about, which is the genesis of all of this work, you do find these, allometric relationships, these scaling relationships, right? And what you often find is that there is indeed, greater efficiency as you go, to larger and larger sizes. So when we speak about, and the way we think about that in terms of scaling is to say that the exponent that describes the scaling relationship is less than 1, right? So these are all, so the human body, if you think about it as a network structure, as the network becomes more efficient, as the body size grows larger, the efficiency is captured by the fact that the scaling exponent is less than 1, usually 2/3, 3/4. Those are the kinds of things that you find. Now, the interesting thing that happened when they did this work on cities was that you definitely found there were quantities for which the exponent was less than 1. Which shouldn't be surprising because you have a background in biology that allows us to think why that might be. But what they also found, which was, I think, more astonishing, more interesting, was that for a number of quantities, you saw exponents greater than 1. So what does that mean? It simply means that, if I go from one city to another city that's double its size, right? There are some quantities that not only double, but grow by more than that, right? So what we then found was that there were basically 3 classes of scaling, right? And different kinds of quantities scale differently. And today we, I think, have a reasonable understanding of what kinds of quantities scales in what way. So if you think about quantities like, network infrastructure. So if you think about things like, road length or, number of street lights, anything that is a network within the city, these are physical networks within the city, because of the fact that cities densify as they grow, these tend to benefit from economies of scale, right? And because they benefit from economies of scale, the scaling exponent is less than 1. By that, what do we mean? If a city of 5 million has a road length of 1,000 kilometers, then a city of 10 million will not have double that length, but less than that. That's where you capture the economies of scale, which is largely a function of densification. The second set of quantities was quantities that scale linearly with population. So a city that is double the size of another city would have double the quantity of certain things. Now, what are these kinds of things? I think a useful way to think about this is personal infrastructures. So if you think about the number of houses or the number of toilets or the number of electricity connections, now these are not going to grow more than proportional population or less than proportional population. They will go in proportion with population, right? Because a house needs one electricity connection, the number of houses is proportional to the number of people. So in that kind of attribute, personal infrastructures, you would expect to see a scaling exponent of exactly 1. And the most interesting thing, the most unexpected thing that we found was that for certain kinds of attributes, like things that we are really interested in understanding about cities, say income, innovation, or even things like crime, epidemics, and things like that, you found that the scaling exponent was greater than 1, which means that for a doubling of city size, these quantities more than double. And there you were asking the question, why is that happening? How, given this network model that we've built of a city, allows us to understand the sublinear scaling of network infrastructure and the linear scaling of housing and other personal infrastructures? Does it also explain why certain quantities like income, innovation, and crime actually grow by more than linearly? And this again lies in the property of the network itself. I think anyone who was, even if you were to imagine a network, you can imagine that as you increase the number of nodes in the network, right, the number of links between them increase more than proportionally. And really, that is the crux of why this is happening, right? So if you think about the kinds of quantities we're talking about, right, income, innovation, these are all formed by connections between people, right? That's where it's coming from. And if the network is densifying, which means that as the city grows, the number of connections that an individual has is actually growing more than proportionally, then that effect shows up in the socio-economic indicators like crime and income and innovation. So it's not just good things grow more than linearly, but bad things as well, like crime grows superlinearly. So that sort of gives us a sense of these various universality classes of urban scaling.
So the universality classes idea also, I think, from its name also says that these are features that are common in more than, say, 1 or 2 cities. These are kind of like seen across cities around the world.
Yeah.
And like you said, some of these quantities, the relationships are almost the same across different cities. So, but I think coming from that would be a nice question of, would then Indian cities as a subset, which is what our interest actually lies in, given that we're also Madras Complexity Collective. The idea is, do you think, or how do you think Indian cities are different? And are they different from around? Do they fall exactly on the line as part of these universality clauses on certain quantities? Or do they say interesting things about how Indian cities are different from cities from, say, the West, which are more commonly well studied over the century?
I think you're absolutely right that often, and this is often a function simply of data availability, is that cities in Europe and the United States are studied often quite deeply. Also because a lot of the research gets done in the West. But one of the things that India has done reasonably well is through the census and some other surveys that are regularly conducted, is that we have a reasonable amount of data, and I'm sure we'll speak more about the data. There are a number of issues and concerns, but there is a reasonable amount of data that allows us to make headway into understanding the Indian city system, right? And especially now, given the framework of scaling, where the nature of what we expect changes, what is happening in Indian cities? So this was a natural question that sort of I was interested in. And we had data on a range of things, including infrastructures like road networks. We had infrastructures data on bank branches, and we had number of electricity connections, housing, toilets, crime. So you had all of this for Indian cities, right? And to start with, we did the simple thing of just asking the question, what are the relationships that we observe, right? And we do find that for most things, the Indian city system behaves just as you would expect from theory and what is observed in other city systems in the US, in Europe, in Latin America, right? So most personal infrastructure quantities would scale linearly. All networks infrastructures like roads, streetlights scale sublinearly, and most socio-economic quantities like income innovation tended to scale superlinearly, right? But, and I think this is important, not everything matched expectations. There were very interesting, and this leads us into questions of history and culture and why they're important. There were very interesting outliers, and I will pick up two specifically. One is personal infrastructures, right? So specifically, we looked at number of toilets in a city and the number of electricity connections. Now, from theory, we would expect that these would grow linearly with population. What we found was that the exponent was slightly superlinear. So it's growing more than linearly. So a larger the city, you're getting more than proportional number of toilets increasing. The second interesting thing was if you look at crime, everywhere that serious crime, everywhere that it's been studied, you find that it tends to scale superlinearly, which means that the exponent is greater than 1. If a city doubles in size, the number of crimes more than double. In India, we find the other end of the spectrum, which is that superlinear crime or serious crimes scale sublinearly, an exponent of less than 1, which means that the crime rate in many smaller cities in India are larger than the crime rates in the larger cities in India on average. So this was, again, very surprising kind of behavior. So in summary, yes, we did find that the city system behaved in ways that we expected in many ways, but I think there were very, very interesting outliers, especially the ones that I mentioned.
Yeah. So then the interesting bit also for us when you think about India is just, the subcontinent is huge. So you have different types. There's regional diversity all around. So apart from just saying Indian cities show these characteristics, even because you mentioned the outliers and how they tell us a little bit more about how different Indian city systems are to the world, like to the global ones, especially the ones of the West. So are there, even within India, do you think different cities behave differently in specific quantities across regions, for example, the North and the South?
Yeah, no, we definitely found regional signatures in the work. So let's actually go dig into the two quantities for which I told you India behaved differently. Let's take the example of something like electricity connection. Why is it that we see that the number of electricity connections increases more than proportionally as we go into larger cities, right? Now, one answer to this, and this I think is very plausible, is that India is a developing country, right? So what you expect is that in smaller cities, not everybody who needs access to the service has access to the service. So access is not, universal in India. So for things like toilets and electricity, it might not be universal, or it might be far from universal in smaller cities. But as you go into the larger cities of India, it is possible that those are the cities where you first start seeing universality, which is that a greater proportion of households have access to these services. So in a small city, if 70% of households have access to an electricity connection, in a larger city, it might be closer to 85, 90%, which explains the superlinear exponent. It's that the rate is changing, right? It's growing over time. So here the expectation would be that over time, as these services become available to everybody, which is the expectation we would have as the country develops and grows, then this exponent will be linear, because then everybody has access, whether you're in a small city or whether you're in a large city. So this discrepancy between behavior in Indian cities and other cities is possibly caused by the fact that smaller cities in India are less well provisioned than larger cities. This also ties in with the fact that if you look at migration patterns in India, right, people migrate from villages disproportionate to larger cities. So there is, you don't see as much migration into the middle tier or the small scale cities. There's a lot of it is going straight to the big cities. And part of the reason could be that, better services are available there, a better quality of life is there, right? Which is not to say that this quality of life is excellent or even good. Yeah. It's just better than what you would get elsewhere. So the second thing where we found was that we discussed was crime. Yeah. And in crime, actually, the regional dimension becomes very, very important. So this was actually very interesting because it was a completely unexpected result. We had not seen anything like this anywhere. The first place we went to was to data, to say, is this data okay? Why are we seeing such a big discrepancy, right? I mean, we might have expected a smaller exponent, yeah, right? Maybe close to linear, but it's significantly sublinear. So in order to sort of make sense, now the data, as far as data is concerned, there's a general problem with crime statistics, yeah, is that for most crimes, people tend not to report, especially in developing countries. People do not want to deal with the police, for various reasons. And, this is quite well recorded. But the one subset of crimes which are actually have to be reported is a crime where there's a body, yeah, right? So if you look at serious crimes, murders and homicide, then the data is generally considered to be of reasonably high quality anywhere in the world. And even that, when we looked at in India, the exponent is significantly sublinear. So this forces us to ask the question, what is it about the emergence of the Indian city system, right? About the history or the cultural aspects of that lead to this difference, right? Because there was no obvious explanation that seemed to be available, that we could just sort of ignore this as an outlier. It seemed to be persistent and it demanded an explanation. So when you look at the crime data in India, especially of serious crimes, you find that the most sort of salient lens to look at it is through the lens of caste, right? Because a lot of crime, serious crime in India is related to issues of caste. As we found out when we looked at the report of the National Council for Scheduled Castes and Scheduled Tribes, who put out these regular reports specifying the kinds of crimes that happen. And in their reports, one of the trends that becomes very quickly apparent is that large villages and small cities tend to be quite, see quite a bit of violent crime, especially serious violent crime. This is largely driven by, issues of caste, right? It's one caste committing atrocities on the other. And usually it's the scheduled castes or scheduled tribes who are at the receiving end of these atrocities. And they also identify the fact that 4 states in India, if I remember right, they're Rajasthan, Madhya Pradesh, Uttar Pradesh, and I think probably Haryana, that account for 60% of all of these serious crimes. And if you look at the urban profile of these states, most cities in these states are smaller in size. The large cities in India, the ones that you tend to think of top of mind, are not in these states. The Delhi, the Bombay, the Calcutta, Madras, Bangalore, Hyderabad, these are not in these states. Yeah. These states tend to have a large body of small and medium-sized cities. So clearly there was something, this seemed to offer some kind of an explanation for what we were seeing, is because crime rates were much higher in these smaller places, and they were correspondingly much lower in the larger cities, right? So therefore, we could see that this was a plausible explanation for why your scaling exponent was less than 1, right? Because the rates of crime are actually decreasing. The second question, and this maybe we can come to later, if we have time, is why? Yeah. Why? Because we just discussed the scaling model and this network structure, which tells us that any of these socio-economic indicators, whether it's income, innovation, crime, whatever it is, because the number of connections is growing more than proportionally as the population size increases, our expectation is superlinear. So why is that not happening here, right? We've done some more work, and we have some preliminary idea. Maybe I'll just wrap up this discussion with the idea that we have is that while indeed it is true that we would expect the number of connections to grow, so that doesn't change. We don't change the model of scaling to understand why this is happening. That is true. Perhaps there is also something about the value of these connections, right? So if connections at a certain distance are assigned different values, even as the network grows, which means the number of connections that you have densifies, if it means that at a certain distance the value of those connections goes down, then it is indeed possible that in this interplay of number of connections and the value of those connections to you, right, you can indeed get sublinear scaling of crime. Right. So as the size of the city increases, right. So for instance, if anyone who's read B.R. Ambedkar, when he talks about the village as a den of violence and ignorance, and he speaks about cities as being emancipatory because they offer anonymity, and that in a sense captures this this term that I'm using, value of a connection, right? In a smaller place, in a village or in a small city, it's easier for you to identify, your co-ethnic or your co-caste member. It becomes much more difficult in a larger city. So the value of a connection is much higher in a smaller city because identification is easier. It's much more difficult in a larger city where identification is much more difficult. You can't form those connections as easily. So if we indeed think about the interplay between these two factors, then it's possible that, despite growing number of connections, you can see sublinear scaling, or at least that's what we theorize as what might be happening in India. Sorry, you would also, so that is one. So while that's a theory that, that could explain what's happening, there's also very clear regional signature that you're seeing. So you have these 4 states, Indo-Gangetic Plain states, where you're seeing these big crimes. And so if you were to actually split India into 2, and just consider, the states along the Indo-Gangetic Plain, along with the northwest, like Rajasthan, and then look at the south and the east and the other states as one, you do indeed find that the scaling relationships for these 2 sets of states are actually quite different. So the scaling exponent, well, 2 things to remember. One, the scaling exponent of the Indo-Gangetic and the northwestern states is significantly sublinear. It's close to 0.6. Right? Which means that the rates of crime are actually going down quite dramatically as you go up the urban ladder. In the other states, you find that the exponent is close to 0.9, right? But still sublinear. So it's not like the problem goes away, it's just much less acute. And that indeed these networks of caste culture is, seems to be playing an important role in determining what we see as a scaling outcome.
That's really interesting. It kind of follows one of the questions I had, which was it's nice to see these relationships develop. As you can see, they're from data, again, from multiple, across multiple cities that you've looked at. So the relationship is more or less similar, is the entire power of a scaling relationship. My question very naively was, there seems to be a lot of interesting patterns you see, but how is it useful in policy, for example? So how do we think about these as a way to as an instrument to say, we can look at a scaling relationship and because of its simplicity, how can we kind of use it as a tool for better policy? Have you thought about any of that in your work?
At the end of the day, these are the reason we study these problems are very much to say, is there something useful we can say that people who work very hard on these can find useful, right? Because it's interesting to find these relationships, and as a scientist, you sort of, that is part of the thrill of working in science. But definitely, I think quite a bit about what is the value of learning these things, and I think there's at least a couple of things. One is, I think in general, understanding is important. Right? What is happening, right? And what we have is a model to explain what to expect also. So if, if you're in a state, say a chief minister of a state in India, and you look at, let's say, if you're a chief minister of Maharashtra, you have both Pune and Bombay, that are big cities in your state. Now, Bombay, let's say, is what, twice the size of Pune, maybe 2 to 3 times the size of Pune. Yeah. And you find that average income in Bombay is higher than Pune. Now, you might say that I want to have the average income of Pune to be the same as Bombay, which is if someone who is not familiar with this work, it's an easy thing to say because why not, right? But if you understand this, you would say that, well, there's a reason why, Bombay is going to be better, right? Or if you want to say, I want to restrict migration, which is a thing that comes up time and again in India, that, how do we keep people in rural areas? Well, is that a desirable thing, right? Because as someone making a decision in a village, maybe your prospects in the village are not great, you're deciding where to move, right? Now, if I look around me and I have choices of Bombay, Pune, Solapur, Kolhapur, the entire, let's say all of Maharashtra is open to me, what choice will I make? It's very likely that I will choose Bombay because I feel my prospects are the best there.
Yeah.
Right? Now, you are not making the decision based on some scaling relationship. You are making the decision based on what you see.
Yeah.
Right? But the state, in telling me that don't move out, I will help you, can never help you in that crude way.
Yeah.
That they will increase rural incomes in that way. Because quite simply, there is something about the network effect. There is something about the way the urban network evolves over time that is producing these relations. These are essential to the way urbanization happens.
Yeah.
Right? So there are certain things that that scaling can tell us, don't bother with this stuff. Right? It's not a good idea. You're going to waste money, you're going to waste resources, you're going to waste time, and you're not going to get anything for it. A second thing I would say is at least what seems to me to come out of all this is that there is a lot of contingency in this, right? While scaling gives us a sense of expectation, cities can overperform their scaling expectations, cities can underperform their scaling expectations. So there is a lot of role for contingency, which means there's a role for the local forces to play out. And they can, cause cities to overperform or underperform on various attributes. What that suggests to me is that big, programs that are one size fit all are probably not a great design.
Yeah.
Right? I mean, in India, we generally understand this because it's such a diverse country, culturally, linguistically, that, we instinctively feel that big programs are not great. But theory here is telling us that, what is happening at a micro scale, you have to pay attention to that. And so you really want to intervene, but intervene where you can get a big bang for your buck, where the intervention is not expensive, right? So that requires, I think, in policy making, a certain sense of agility, a certain sense of going more local, right? Which means that decision making at a concentrated level, because in India, states can be 100 million people, right? That's pretty big, right? Most of our states are bigger than lots of nations, right? So, again, that kind of agility, that kind of, working at a lower sort of level of disaggregation, I think those are important things that this tells us. And apart from this, depending on the specific question that you're looking at, there might be specific answers that scaling can give you. But I do feel that these big, broad lessons are in themselves quite important. Because as you know, in India, we tend to sort of have a fascination with big programs. So we had the JNNURM, right? Jawaharlal Nehru Urban Renewal Mission. I think that ran for about 10 years. And then we have the smart cities missions.
Yeah.
So we have this sort of fascination for big programs. It's not clear to me that given the diversity, given what theory is telling us, that those are the best designs for us to think about our cities.
Yeah. So in general, like population aggregating to like an urban area is more like a systemic kind of evolution rather than you having to fix one thing and then people migrate.
Exactly.
It doesn't happen like that.
And our sort of instinct, I feel, is to intervene.
Yeah.
Because it feels like we're doing something, and perhaps there is a value to actually taking a step back and understanding some of these things so that your intervention can be the most efficient interventions, right? Because we are not, India is not a country where public money is flush. So you really want to use what money you have, get the most bang for your buck, right?
Okay, so then, okay, couple of questions there which are more around, the constraints of doing this work, say, would be around data, obviously. So in general, if you spoke to me about Indian cities, my first question would be, what is an Indian city? Because if you look at administrative boundaries, you have like ideas of districts, major towns, urban agglomeration, stuff like that. And then, while in common parlance, you have the idea of a city, and we think typically of metropolitan areas. So, and data collection is not geared towards this idea of studying a city. So, kind of, what are your experiences with that? How do you think also can we fix this if, say, we had the chance to recommend something to a policymaking body about data collection?
So, yeah, I mean, data is a huge concern. I mean, I had earlier mentioned that, what data we have allows us to make an entry into understanding the Indian city system, but it's nowhere close to being sufficient to understand it well. And I think you hit the nail on the head when you asked the question, what is the city, right? In the previous discussion, I think we had this very interesting debate on how to come up with a definition of the city, right? Where you don't define the city a priori, right? You don't come in with the definition comes from the theory. And urban scaling as a theory actually comes up with a definition of what a city should be, right? And this is what we call a commute to work zone, right? Yeah. Which is a combination of the places where people work and live. That is the extent of a city. Now, traditionally, the way cities are defined are usually, based on some sense of traditional administrative boundaries, some sense of, living densities, infrastructure availability. And these are the criterion through which we tend to define cities. Now, over time, but this does not capture the way that a city is defined in urban scaling, which is this functional definition or a commute to work zone, right? And this is a problem because in 2011, in the census, they actually captured a lot of data at the level of cities in India, right? And across a whole range of attributes, which is what we've actually used in our analysis. Now, if you were to use that raw data and assume that definition of a city as given, I think you might come away with a very, how do you say it? A misjudged sense of the Indian city system. Because if you take a city like Bombay or even Madras, right? What is considered, the district of Chennai is not the city of Madras. Yeah. Or what is considered Bombay is not the city of Mumbai. It includes a whole range of other areas. In fact, most of your population might be living outside what you consider. So how do we come up with data for this? Now, the census, to give them credit, they did try to address this problem through what they define as an urban agglomeration, which is they understand the problem that, what is, Chennai district is not it's not Madras city or Chennai city, right? You have to consider areas around it. And the way they go about doing it is again using, similar metrics to say that if areas around a city have a certain density, have access to certain kinds of infrastructure, then those are included in the urban agglomeration. So using this, we were able to construct a set of urban agglomerations for India, which is what we use in the analysis. Mm-hmm. Now, as you can immediately, understand from that, this is not the functional city. Yeah. It is at best an approximation. This is what we are working with right now. Now, can we do better? I mean, we can do better because now, given access to, GIS data, given access to cell phone data, we can perhaps do a better job of constructing that network structure of a city. What are these commutes that are happening? Where are people going? This should be possible at this point. And given that in India, we generally see a trend towards the use of technology across many different areas to solve a problem. This is a problem that actually can be solved through technology, right? So perhaps that is a thing that, the census, which has now been postponed for 3 years, hopefully we'll see it happen next year. They could actually try and do something like this to construct, a more functional view of a city. So that's important, right? And once we get that, we can speak much more confidently about these things happening. A second thing that I think is important that stands out, and given that the importance of urbanization is no longer a secret in India, to this date, we do not have a reliable data series on urban GDPs, right? So if I wanted to know the GDP of Bombay or Bangalore, I don't have a reliable data source. I mean, different, consultants try and estimate this and that, but, and those estimates are often quite different from one another. So you really don't know, what we are looking at here. Now, we have done some work on this, and we use district level data to construct a sort of a measure of what a city might be.
Yeah.
And we could basically try and approximate about 25 cities like that in India, right? But this is obviously not a desirable, state. You really want to have reliable data on your most important cities because these are at the forefront of India's growth, right? They're also at the forefront of so many of India's problems. But the question is, do we understand these problems well enough? And is the data that we have reliable? And on that, the 2011 census also did what I think for the first time a slum census, where they went and collected data on slums. Now, this has been criticized a lot, this data collection, that slum populations, for instance, are quite egregiously undercounted and things of that nature. And this is very possible. But again, we are often told about what, the big problems in our city is overcrowding, the state of life in slums, but we really don't have a good sense of, what actually is the state that people are living in. At best, we have some sort of a visual sense, but is that good enough for you to make good decisions about, how to provide infrastructure, how to, aid people who live in these, often unhygienic conditions, what needs to be done? Well, then we really don't have access to good data to answer those kinds of questions. So I would say there are very, very big gaps that currently exist. But given the start that's been made in 2011, I feel more hopeful given the use of more technology, maybe through the involvement of more people who actually live and work in slums in the process of data collection. Maybe we could construct much better understanding of our urban condition today.
So just before we close, I wanted to just follow up on that. So maybe the slums is an interesting point because slums are quite, maybe not unique only to India, but definitely in comparison to Western cities, are a unique feature of city systems in this part of the world. So like you said, data is bad. It's hard, also obvious for obvious reasons. It's hard to collect data from slums. But I know you've done some work thinking about scaling relationships in slum populations with city sizes. Maybe some interesting results from that.
Okay, so again, this confirms something that we discussed earlier. One of the results we saw was that the slum population of a city increases superlinearly with the city's population, which again just simply shows that migrants are moving to larger cities when compared to smaller cities, and you see that in that scaling relationship, right? So that is one thing that is very clear. Then we see, well, there are two axes in which we looked at it. One is to say, how do you look at slums in a city in contrast to other neighborhoods in a city? And the second axis was, how do you look at slums across city sizes? So how are slums in smaller cities different from slums in larger cities? And if you look at the axis of, across city scales, you again find that slums in larger cities tend to be better provisioned than smaller cities. So for instance, even infrastructures like private toilets, which are, within individual homes, you find more individual homes within slums in larger cities have toilets than ones in smaller cities. So clearly there is the scale effect that infrastructures are first being provided to slums in larger cities. And, maybe there is again an urban hierarchy at work there that, this will have to flow down the hierarchy for us to see improvements in smaller cities. And no surprise, of course, slums are much worse off than other neighborhoods in the city, which means that, all the economies of scale that we spoke about are not actually fully being exploited. Because if you consider the city as a whole, with its slum and its non-slum neighborhoods, and you really were to, generate benefits of economies of scale, you could, actually see slums being much better off. But clearly that is not happening. So those two axes, you clearly see that, there are these behaviors that emerge. And I would say that, again, there's a regional signature to this as well. That, slums in the states of the Indo-Gangetic Plain are generally worse off than slums in the rest of the country, in the south and the west. So again, there is a very clear, regional signature that you see there. But, as I said, I think on slums, we could just, make these, I would say, initial sort of findings or observations. And we didn't want to, over reach, given the data that we had, to say, more. But, hopefully with more, hopefully with the new census and what they put out, we will also get a sense of dynamics over time, because that we currently are unable to do, right? So, and also given the fact that over the last 15 years, India has seen a lot of growth. Question is, where is that growth going? Because there is a distributional question. Average rates of growth do not tell us about what is happening, who is benefiting from the growth. There's a lot of concern in work that we have done that shows that a lot of that growth is going to, the upper ends of the income distributions. And perhaps, the slum census will allow us to identify, what's happening in slums when India is supposed to have seen this decade of, very high growth.
Okay, so maybe to close off, would be interesting to know, like, maybe concisely what you think would be, because of the complexity collective that we have, and we want to do more work on this. Maybe like interesting research directions that follows from this idea of science, like the science of cities, and especially studying scaling relationship cities. What would you think are like maybe the things to focus on for us in a couple of near future?
So I guess what comes to mind right now is what I just said to you, which is that temporal dynamics, we don't have a great sense of, because, we just don't have access to that kind of data. But hopefully with the new census, now we can start getting somewhat of a sense of what has been happening over the last 15 years, right? But we don't know when that next census is going to happen. But that is something that would be very interesting to see. While we are at a cross-sectional level, we are observing a lot of these relationships, but over time, what is happening. The second thing that I think, we need to get a much deeper sense on is urban inequality. All studies of both poverty and inequality happen at an all India level, at most at a state level. And we ourselves have done some of the work more recently. And what we are finding is very concerning. Right? About the kind of growth or degrowth that we are seeing at the bottom of the income distribution in India. To actually disaggregate that and to be able to say what is happening in the cities of India, I think is a very important question. Because while we are all caught up in the Indian growth story right now, this revolves around very, very average numbers, average income, average growth rate. It completely ignores questions of distribution. And I feel we really need a very good handle of what is happening there. Are the benefits of that growth actually reaching out to, the people who are really in need, right? Who are building the cities that we are seeing in front of our eyes. And the third direction that I'll be very interested in seeing more work happening in India is areas of pollution and climate change. Not just scaling, but in general, can a science of cities help throw more light on what we are observing, what are the measures that are being taken, what is failing? We do have some work on this, obviously. But is there a deeper understanding that we can generate on those fronts?
Okay, so that's good. I mean, we'll continue these conversations, and maybe we can get more interesting guests like we had before from different geographies to talk to us more about like scaling relationships, science of cities, inequality, all that. So, yeah. Thank you for that.
Thank you so much. I also look forward to doing more on the Madras Complexity Collective, getting more people who work on these questions. And I think most importantly, like you said, getting people who work across, very different parts of the world, who are working with under a lot of different kinds of constraints and struggles. And what are they finding? I think, to truly build a science of cities, we really have to understand context.